I am Michael Carstensen. I am a professor at Technical University of Denmark, and I also have a company on the side that makes instrumentation for food safety, food fraud detection. I think the demand is to have a method which is fast, non-contact, and also applies to a wide variety of quality parameters in food fraud. It can be parameters in terms of chemical differences, composition. It can be shape, size. It can be texture differences. So we go for all of these different cues on the same time when we detect food fraud. So the technology we're interested in is only imaging from our side. So LED spectral imaging is an imaging technique where we have a camera. It's looking through an integrating sphere, which is a hollow white painted cavity. And we strobe different LEDs into this cavity, and the light will bounce back and forth and end up on the sample in a very homogeneous way, in a very diffuse way, so that we take away specular effects from the sample, topography, shading, and completely focus on surface chemistry. And we basically make a spectral image of a food sample, and then we use the spectral image to sort of create an abundance map of different types of composition, different types of chemistry in the sample. The places where we imagine this technology and where we see it already today is the people that do trade with food, the incoming harbors, the laboratories, the government labs that investigate potential fraud, and also the big companies that have brands they want to protect, and finally even the producer that takes some incoming product and process it further on. They can be interested in avoiding adulterated or potentially unsafe product coming in. It is commercialized right now. So actually the first version came out in 2005, so we have been on the market with this for 9 years. The places where we have detected potential problems with the quality of food is, for instance, the malting industry, where we have incoming barley for the malting process that may contain fusarium, and we try to screen the incoming barley for fusarium, and the maltery will then base an accept or reject decision on the incoming barley based on the results from our instrument. You throw a handful of barley kernels in a petri dish, you put it into the instrument, it will show you exactly where you have potential fusarium. Fusarium is a mold that creates or may create mycotoxins, which may end up in the beer. So simply to avoid the potential of having mycotoxin in the beer, we screen the incoming barley for fusarium. You don't have a sample preparation where you need to homogenize your product before you measure it or scan it. We can measure directly on the product, it being meat or grain or powder or tablets. This creates a possibility to do things fast, non-destructively, and that means it can be combined with more elaborate methods where that takes longer, are destructive, like PCR or mass spectrometry. It can do that in terms of picking out suspicious samples for these non-destructive and more time-consuming techniques, more expensive techniques.